Hello everyone. Since some student has asked, I would use this video to clarify what we mean by proof by contradiction. Let's call our normal proving method the straightforward method, or simply the forward method. So where we have a proposition, which is the statement to be proved. The example of it would be like this equation to be proved, or simply a statement like it is raining. Okay, in our proof, we always start from simple known fact and step by step and connect to what we know to the target proposition. Therefore, a formal proof process is a process to establish implications from the known truth to the target proposition. Therefore, in simple words, we want to attempt to connect what we know to what we want to know, and finally arrive at the target proposition. If that connection is achieved, we say the proposition is proved. Note, however, on each of these steps, you must know the sort of truths that all agree. So, which means you must convince everyone you really indeed can establish every line of the implicitation from A to B, from B to C, and step by step, finally, everyone agree that you can prove the final proposition. So that's our normal forward proof steps, and from connecting what we know to the final target step by step. In proof by contradiction, however, we assume the contrary is true. And once again, for example here, we assume P naught is true, and then again we must convince everyone that we can step by step derive some more statement, and after statement, for example, arrive at X. But this time, what our goal is to look for a contradiction. For example, here, if you have P, you arrive at another statement X and another step Y, and maybe more step in the middle. But as soon as there's a negation of a previous step, and then you're done. Over here, so here is X. If X not come out, we're done, because this means there's a contradiction is observed. So that then we can conclude the proposition is true. That's what meant by proof by contradiction. Once again, proof by contradiction is derived from the contrary step by step. Every step you will have the truth and connect to the known truth, that in terms of the theorems, axioms, the facts known. And in other words, you have to convince everyone so that you can indeed establish such an implicitation at every step. And until as soon as the negation occurs, you're done. So that is proof by contradiction. Let's look at some examples. Okay, this is the example from our textbook, proof by contradiction. You're asked to prove this logic identity. So here, and in part, additionally, we sort of forgot in here, you should be a parenthesis, which means and operator will have the first highest precedence. So this is what to be proved. Therefore, this is our P. Okay, follow this proof contradiction. And then we assume contrary is true. So which means if they are equal, so which means one side is 0, the other side has to be 0. But now if the contrary is true, the other side is different, so the other side is 1. So this is 0, the other side is 1. So therefore this is, we suppose this is the contrary. Now, from contrary, we derive at the next step. So then from the contrary, we can find which is this we call our X. So from here, from contrary, we can arrive at this X here, and then X or Y equal 1. So that's where we're starting. And then we move on. So things from the first step, since the left-hand side is that's 0, implies that x0 and this to 0. That's a definition of, so this is again that. Okay, that's an OR. So this OR means if the OR is 0, both sides is 0. So and that. So this is counted as what do I say? Truth. That's we all agree from here. Okay, whatever x. So we are going through this step. So x and truth will agree. Okay, truth will agree, and goes to the next step. We will call it x, and truth we will call it this step y. And then from 1, x equals 0 and that equal 1. So that's because both that should be 0, that should be 1. And then implies that, so this is also truth that we all agree. So you must follow this idea, even though there are so many different theorems, but you should have the clear what you try to derive the new statement. So then important here is this is the end between these. So this is the end, and then and this is true, implies y equals 0, and that is the end. That's an end there. And then you derive at another conclusion from here. So you can read. And then here is x naught. So here you have x or y equal 1. From here you can have x or y equal 0. So then there is a contradiction is observed from here to there. Therefore, we're done. The proof by contradiction. So that's the example. Follow this pattern. Of course, there could be more steps. Very importantly, here is a operator is an and, not or. But see, if what counts as the incomplete or invalid proof would be that you're not really established this link. For example, your so-called truth may not be incorrect, or you don't know the theorem, or you put this or, which means then you will not have a valid proof. So that's it. Hope this is helpful.